Hello students, welcome to our student support program for grade 9 mathematics. Our topic for today is probability. This is the third lesson on probability. In today's lesson, you will learn about the possibility diagram. So let us have a look at today's learning outcomes. In this lesson, you will learn how to construct and use simple possibility diagrams to find probabilities. Before we start with a possibility diagram, let us have a quick recap on what is meant by probability. You will remember that probability means chance. Probability is a measure of the chance that an event will occur. For example, there is 60% chance that tomorrow you will forget your lunch at home when going to school. So when you roll a die, this is called an experiment or a trial. An outcome will be the result obtained from an experiment or a trial. For example, when you're going to roll a die, the possible outcomes will be obtaining 1, 2, 3, 4, 5 or 6. So we write 1, 2, 3, 4, 5, 6 between brackets, and this is called the sample space. So the sample space is the set of all possible outcomes of an experiment. Let us have a look at this example. A fair coin is tossed. List the possible outcomes. Do you still remember what are the possible outcomes when you toss a fair coin? So, the possible outcomes are head and tail. You can either get a head or a tail. An event is the set of outcomes of an experiment, and it is a subset of your sample space. So for example, when you're going to toss a coin, obtaining a tail can be defined as an event. Remember, we have just seen that the sample space will be head or tail. So obtaining a tail will be defined as an event, and it is going to be a subset of your sample space. Now, what is the definition of probability? How do you calculate probability? So the probability of an event E, denoted by P bracket E, is calculated as follows. Probability E equal to total number of outcomes favorable to event E over total number of possible outcomes. So the total number of possible outcomes will be all the outcomes found in the sample space, and in the numerator it will be the number of outcomes which will be favorable to event E. Let us have a look at an example to understand what is meant by probability of E. A fair coin is tossed. Find the probability of obtaining a head. So we have just seen that when you toss a coin, the possible outcomes are head and tail. So the possible outcomes are head, tail. Now, probability of getting head, we have only one head. So the numerator will be 1. Number of outcomes favorable to E, that is here E will be obtaining a head. We have only 1. So 1 in the numerator divided by the total number of possible outcomes. So here we have 2 possible outcomes. My numerator will be 1 and my denominator will be 2. So probability of obtaining head will be half. Let us look at this example. A box contains 4 red pencils, 3 blue pencils, and 5 black pencils. A pencil is drawn at random from the box. What is the probability that it is part A, blue, part B, red or black? So you have a question here. We have 4 red pencils, 3 blue pencils, and 5 black pencils. How many pencils do we have in all? So, total number of pencils will be 4 red plus 3 blue plus 5 black. That is a total of 12. We have 12 pencils. This means that in our denominator, we will have 12. The total number of possible outcomes will be 12. Now, probability of getting a blue pencil. So, how many blue pencils do we have? We have 3. So, the numerator will be 3. Probability of getting a blue pencil will be 3 over 12. Reducing to lowest term, we will get 1/4. Remember, you should always reduce your answer to its lowest term. So, probability of getting a blue pencil is 1/4. Part B now, probability of getting a red or black pencil. So, we have 4 red pencils and 5 black pencils. So, probability of getting red or black will be 4 plus 5, that is 9, over the total number of possible outcomes, which is 12. 9 over 12, reducing to lowest terms, we get 3/4. So, probability of getting a red or black pencil will be 3/4. Now we move on to the possibility diagram. So, these are some examples of possibility diagrams, and we will learn now how to draw these. So, what is a possibility diagram? A possibility diagram is used to show all the possible outcomes of an experiment. Instead of listing them in set notation as we have done previously, we are going to use a diagram to illustrate all the possible outcomes. Let us have a look at this example. 2 fair coins are tossed at the same time. Illustrate the possible outcomes on a possibility diagram. Hence, write down the probability that the coins show part A, 2 heads, part B, a head and a tail, part C, at least 1 tail. So, we are going to learn how to draw the possibility diagram. Remember that when a fair coin is tossed, the possible outcomes are head and tail. You can either obtain a head or a tail. So this is for 1 coin. But in this example, we have 2 coins. So for the first coin, coin 1, I'm going to draw it here. Coin 2 here. First coin, I can have head or tail. For the first coin, I can have either a head or a tail. For the second coin also, I can have either a head or a tail. Now, when the 2 coins are tossed together, I can obtain head, head, or head, tail, or tail, head, or tail, tail. I can write it in this way. The first coin will have as possible outcomes head, tail. The second coin will have as possible outcomes head, tail. So I can get head, head, or head, tail, or tail, head, or tail, tail. So these possibilities can also be written in this way: head, 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 tail, tail, head, or tail, tail. You can either represent it in this way or in this way. Now, probability that the two coins will show head. That is, the coins show two heads. So, probability of getting two heads, we have only one possibility here, to get two heads. And how many possible outcomes do we have? Yes, we have 4 possible outcomes. So, the answer will be 1/4. Part B now. Probability that the coins show a head and a tail. So in this question, we need to find the probability that the coins show a head and a tail. Now, it can either be coin 1 showing head and coin 2 showing tail, or it can also be coin 1 showing tail and coin 2 showing head. So, we have probability of head, tail, or probability of tail, head. So, the first coin will show head, second one will show tail, or the first one will show tail and the second one will show head. Now, we look at the diagram. So, probability of getting head, tail, or tail, head. We have 2 possibilities. And the total number of possible outcomes is 4. So, I'm going to have 2/4. Reducing to lowest term, we have half. So, probability of getting head and tail will be half. Part C now. Probability that the coins show at least one head. What does it mean, at least one head? At least one head means minimum that I need is one head. I can have more than one head. And in this case, I can also have 2 heads. So probability of getting at least one head means probability the coins show one head or 2 heads. One head can be head, tail, or tail, head. We have just calculated it in part B. And 2 heads we have calculated in part A. So 2/4 plus 1/4, which is 3/4. I repeat, probability of getting at least one head means I can get one head or 2 heads. One head will mean tail head or head tail. And 2 heads, you have it here. So in all, we have 3 possible outcomes. So 3/4. Now, let us move on to the next example. A red and a blue fair dice are rolled together. Construct part A, the possibility diagram to display all the possible outcomes. Part B, hence find the probability of obtaining. We have 6 parts here and we are going to look at each one of them. So, first part, we need to draw our possibility diagram. So, for the first die, we will have the following possible outcomes. 1, 2, 3, 4, 5, 6. For the second die, we will have the following possible outcomes. 1, 2, 3, 4, 5, 6. Now, we are going to combine these possible outcomes because we are having the 2 dice rolled together. So here we will have 1, 1, 1, 2. I write it here in coordinate form. 1, 3, 1, 4, 1, 5, 1, 6. Similarly, you will have for die 2. You can get 2, die 1, you can get 1. So you will have 2, 1, then 2, 2, 2, 3, and so on. In the same way, you can have 3, 1, 3, 2, and so on. Similarly, we can fill in the table here and you have your possibility diagram. So how many possible outcomes do we have here? We have 6 possible outcomes in the first row, 6 possible outcomes in the second row, and so on. So the total number of possible outcomes will be 36. So when we are going to calculate the probability for the different parts in part B, the numerator we need to find, but the denominator will be 36. First part, probability of getting 2 sixes. So let us see in this diagram, how many times can we get 2 sixes when we roll 2 dice together? We have only one possible outcome. Only one time can you get 2 sixes together. So the probability will be 1 over 36. Second part, probability of getting doubles. What does doubles mean? Doubles mean getting 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Doubles mean you're going to get the same number on both dice. So we have 6 possibilities here. 6 possibilities. So 6 over 36. Reducing to lowest term, we get 1 over 6. Third part now. Probability the sum is 9. So I'm going to draw a second diagram now to find the sum. So here we have the possible outcomes for the blue die, the possible outcomes for the red die, and we are going to add. So getting 1, 1 will mean a sum of 2. Getting 2, 1 will give me a sum of 3. Getting 3, 1 will give me a sum of 4. So I'm going to fill in the table in the same way. For example, getting 5 and 4 will give me a total of 9. So probability that the sum is 9. Let us see how many times we have 9 in this diagram. 1, 2, 3, 4. So probability that the sum is 9 is going to be 4 over 36. Reducing to lowest term, we will get 1 over 9. Next one. Probability the sum is less than 7. Less than 7 means 2, 3, 4, 5, and 6. I didn't start with 1 or 0 because we cannot get a sum of 0 or a sum of 1. So sum less than 7 will be 2, 3, 4, 5, and 6. Let us count how many times we get these numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So the probability will be 15 over 36. That is 5 over 12. Next part now. Probability the product is 12. So here we are going to draw a new diagram, and this time we are going to have a product times. So we are going to multiply the scores. 1 times 1, 1. 2 times 1, 2. 3 times 1, 3. And so on. For example here, 3 times 2, 6. 4 times 3, 12. So we need to find probability of getting a product of 12. Let us see how many times 12 appears in my diagram. 1, 2, 3, 4. So the probability will be 4 over 36. That is 1 over 9. Next part. Probability is at least 24. This means that you can get 24 or more than 24. The minimum should be 24. So it can be 24 or more. Let us count. 1, 2, 3, 4, 5, 6. So the answer will be 6 over 36. That is 1 over 6. Now we move on to the next example. A six-sided ordinary die and a fair coin are tossed together. Part A, draw a possibility diagram to represent the possible outcomes. Part B, hence state the probability of obtaining, first part, a 4 and a tail, second part, a head and a prime number, third part, 2 sixes. Let us have a look at the solution. So the possible outcomes when you toss a die are 1, 2, 3, 4, 5 and 6. The possible outcomes for a coin, head and tail. Now if we are going to toss a die and a coin together, the possible outcomes will be, as you can see in the possibility diagram, you can have head for coin or tail. Die 1, 2, 3, 4, 5 and 6. So you can get 1 head or 1 tail, 2 head or 2 tail, 3 head or 3 tail, and so on. Now part B, probability of getting a 4 and a tail. So you can see here that we have only one possible outcome. 4 and tail, we have only one. And how many possible outcomes do we have in all? 12. So the answer will be 1 over 12. Second part, probability of getting a head and a prime number. Do you still remember what are prime numbers? So a prime number is a number which is divisible by 1 and itself. So here the prime numbers will be 2, 3 and 5. So head and prime number, I'm going to have 2 head or 3 head or 5 head. So we have in all 3 possibilities. 3 over 12, which is 1/4. Next part, probability of getting 2 sixes. Is it possible for you to get 2 sixes when you're tossing a die and a coin? No, we cannot get 2 sixes. So the answer will be 0. So whenever an event cannot happen, the answer will be 0. And remember that probability can never exceed 1. If ever we get probability of 1, this means that we are sure that this event can happen. So you have some exercises now for you to practice on probability. In today's lesson, we have learned how to construct and use simple possibility diagrams to find probabilities. So we have reached the end of today's lesson on probability. Until we meet again, it's goodbye from me.